My name is Simon Berman. I'm a graduate student working with Turgay Uzer. I apply nonlinear dynamics to problems in atomic physics. So what I'm going to talk about today is how to extend this to two-dimensional maps which are invertible, where you have not only knowledge of what happens in the future, but knowledge of what happens in the past. And these unimodal maps are not invertible. Any point can come from two places. So you can't uniquely pick a point in state space and say, where did it come from and where is it going? So the two-dimensional maps are going to allow us to do that, but in very close analogy to what we were able to do with the tent map, we will be able to consider a very simple two-dimensional map, which we can enumerate the symbolic dynamics, and that'll turn out that that'll be a straightforward extension of the tent map symbolic dynamics, and we'll be able to apply this very simple two-dimensional dynamical system to understand the dynamics of any stretch and fold type dynamical system, like we are able to use the tent map to understand any 1D unimodal map. So that's the idea of the class today. The 2D map that we'll start with, it's called the baker's map. The Danish pastry in the book is how it's referred to. The Danish pastry is just a tent map forwards in time and a tent map backwards in time. So its symbolic dynamics will just be the symbolic dynamics of two tent maps on a plane. The Danish pastry map, or the baker's map, is specified as follows. You start with the unit square. First, we stretch by 2 in the horizontal direction and squash by half in the vertical direction. Then I'm going to cut in the middle, and I'm going to take side B and bring it around and under like that. What we now have is what we started with, but A is stretched and squashed on top, and B is stretched and squashed on the bottom, but upside down. We are starting to get this stratification along the vertical direction. And to clarify that, I'm going to apply the baker's map again to this, and you'll see how the vertical stratification is going to get more intense and hopefully more clear. What I should make clear is we are going from the full unit square back to the full unit square, because the amount we stretch in one direction we cut by half in the other. But now you see we have these 4 layers of stratification, and we can assign a symbolic dynamics to this going forward in time, and we'll start writing it down, and then I'll assert that it's exactly the same as the tent map. Initial regions that we start with are going to be marked along the horizontal of the original square that we started with. The regions that we get mapped into are vertical regions. Initially, anything that started in the left half ends up in the top half after one iteration. The first symbol that is given to anything over here is 0. And anything that starts on the right half in the end ends up here. So the symbol given to the right half is 1. Because we've done the map 2 times, we know what will happen under 2 iterations, so we can create a subpartition. And so we notice that anything on the left half of the left half, after another iteration, it will still be in the top half. The symbol we can give to this left partition is 0, 0. Now let's consider what happened to the right half of the first left half. Well, we know after one iteration of the map it was in the top, so its first symbol is 0. But after another iteration, the right half goes to the bottom half. So its second symbol is 1. So we get 0, 1 here. And now we repeat the same thing for the initial right half. We break it up into 2. And we look at the left half. The region that started here has now moved over here after one iteration. And then I stretch, cut, and bring this down here, and it ends up here. So its second symbol is 1. If you can kind of guess that the last thing has to be 1, 0. So these are the 4 symbols that I've now subpartitioned my initial square into, and then I just look at the tent map and I say, hey, it's exactly the same. 0, 0, 0, 1, 1, 1, 0, 1. The spatial ordering of these time itineraries is the same as for the tent map. And that shouldn't be very surprising because we're actually doing the same thing here as we do in the tent map. We multiply by 2, and anything on the right side, we multiply by 2 and reverse spatial orientation and bring it under. So we can take our square and along these vertical lines subpartition our state space and figure out what is the symbolic dynamics of all these vertical strips.